Hello, good morning and welcome. My name is Chris and I'm super excited that we have the next 20 minutes to chat about HTTPS only. This new security enhancing feature is in fact available for all Firefox release users since Firefox 83. You probably know that HTTP is the fundamental protocol of the web and it enables all communication between the browser and the server. The downside of HTTP is that it transfers data in clear text, granting attackers the ability to eavesdrop or even tamper with the transmitted data. Carrying HTTP over TLS or short HTTPS solves this security shortcoming by encrypting all the data that is transferred between the browser and the server. We have realized that more and more websites become available over HTTPS, and that the web in general is migrating towards HTTPS. But let's take a step back and actually look at the current connection model in the browsers out there. Currently, if you enter an HTTP URL into a browser's address bar, like in that specific example, HTTPexample.com, then the browser would connect using the insecure and outdated HTTP protocol. Similarly, if you would omit the scheme and just type example.com into the address bar of a browser, then the browser would also connect using HTTP. And furthermore, if you click an outdated legacy link on a website that is an HTTP link, then the browser would also connect using the insecure and outdated HTTP protocol. Probably, or we think the reason for that is that HTTP was the default protocol of the web and it has also not changed after the introduction of HTTPS. The idea of HTTPS only is in fact quite simple. Try to upgrade as many connections to HTTPS as possible. So if you take another look at HTTPexample.com, if you would type in that into the URL bar and HTTPS only mode is enabled, then our approach would upgrade the connection to HTTPS. In a nutshell explained, this is basically what our approach is doing, but obviously there is way more technical details that I would like to discuss with you in the next few minutes. Let's take a very close and precise look at the current connection model. Let's start with number one here. A browser initiates a GET request to foo.com. If the server foo.com is properly configured and uses the best practice, then it would simply redirect the request to HTTPS. The browser, number 3 here, as illustrated number 3, would then send a GET request using HTTPS. And from that point on, the browser could send the HSTS strict transport security response header, signaling the browser that the web server prefers HTTPS connections. Every subsequent connections to the web server would then actually be made using HTTPS. The problem, and as illustrated in here in red in that example, is that the initial request happens over HTTP, which already grants the attacker the ability to intercept that initial request. Again, the HTTPS only connection model tries to flip the model simply around and send an HTTPS request to the web server first. And only if the web server returns an error or says, oh, I'm not available, this request is not available over HTTPS, then HTTPS only grants or shows an exception page to the end user, granting the end user the ability to either abandon the revision or connect using the insecure and outdated HTTP protocol. Again, and it's worth emphasizing that our approach does not want to eliminate the reachability of HTTP websites, but we want to flip the model around and first try to connect using HTTP. Again, if the website is not available over HTTPS, then we show that kind of exception page. And also important, telling the end user, please don't enter confidential information like passwords, credit card numbers, and so on. One of the big problems is that we have to implement some kind of mechanism that can deal with timeouts. And in particular, if you send an HTTPS request that gets blocked by any kind of firewall, for example, then the connection is simply dropped and the browser would not receive any kind of information that the website is not available over HTTPS, right? So we have studied those exceptions, and we came up with an approach that can fight those timeouts. And any feasible implementation of HTTPS-only mode has to implement a very similar mechanism. But let's take a closer look. So the browser sends an HTTPS GET request to foo.com. And then we wait 3000 milliseconds. If the server responds within the 3000 milliseconds, then it's all good. And from that point on, we simply connect using, everything happens as would happen if the initial request is HTTPS and nothing further happens. But if the browser does not receive any kind of signal from the web server within those 3000 milliseconds, then we send another background request using the HTTP version, right? We strip any kind of path, we send an anonymous request, meaning no cookies, no storage in the cache whatsoever. But the critical point here is, and worth emphasizing is, if that request comes back first, like if the background request returns a result before the HTTPS request, then this is a very strong signal that the website is not available over HTTPS. And in fact, the request will result in a timeout, and hence we show the exception page once again. This happens for top-level requests. And then we have everything in detail in the paper, obviously, but I want to highlight two implementation things that are worth pointing out, because any feasible implementation of HTTPS-only mode needs to deal with two very critical security mechanisms within every browser. The first one is the mixed content blocker. And let me guide you through the example here in the code. If the top level URI is not HTTPS, then there is no job to do or to perform for the mixed content blocker. And this is also not special for HTTPS-only mode. This happens for every single request within the mixed content blocker, even without the HTTPS-only mode. If the scheme of the request is also not HTTP, then there is also nothing to do for the mixed content blocker. And here is the critical sauce for our implementation. If HTTPS-only mode is enabled and the load is not exempt from HTTPS-only mode, then our implementation, we modified the mixed content blocker to basically allow list that request with the promise that later in the networking library in Firefox, the request will be upgraded from HTTP to HTTPS. Similarly, we have to modify the interaction with CORS. CORS, cross-origin resource sharing, as the name implies, it has to deal with the same origin policy, right? And two requests are same origin if the scheme host and port are same origin. So now what does that mean for HTTPS-only mode? Well, in fact, that means if the top level request is HTTPS and the sub-resource request is HTTP, then we have some kind of same origin policy violation. And in that case, what we do is we basically extend the same origin policy check here a little bit and just compare the two hosts. If those are equals and only the schemes differ in a sense the top level one is HTTPS and the sub-resource one is HTTP, then we don't initiate a CORS request because in fact, and again, the sub-resource load will be upgraded to HTTPS in NECO, the networking library in Firefox. Those are the implementation details which we have time for to inspect within that short 20 minutes. But again, all the details are obviously in the paper. The state of the internet. And this is also information that Mozilla reports to Let's Encrypt. So if you're interested about that kind of data, you can find the latest numbers on the Let's Encrypt webpage all the time. And this has also nothing to do with HTTPS only mode. This is simply the state of the internet before we started doing HTTPS only mode. And it shows websites loaded using HTTPS. As you can see, in 2015, only like 5 years ago, not even 50%, in fact, not even 40% of websites were loaded using HTTPS. In 2016, Let's Encrypt launched, and we think, or we attribute a lot of changes to Let's Encrypt, and that automatic certificate generation helped a lot to migrate the web towards HTTPS. As we can see here, in 2020, we hit over 80%. And this is the global statistics. Like in some states, like for example, in the United States, we hit over 90% already here. Okay, again, this is the state of the internet even without HTTPS only mode. So now let's take a closer look what we have been doing. Again, as I mentioned in the beginning of this talk, HTTPS only mode is available in Firefox since Firefox 83, and that launched on November 17th, 2020. And then for one full Firefox release cycle, we recorded information which I'm going to show in the next few slides. Overall, we had over 100,000 Firefox release users who opted into using HTTPS only mode and agreed to report information back to Mozilla. This is actually already the critical source and the most important slide in my personal opinion, and it shows the success rate of top-level upgrades. On the left-hand side, we see that 2/3 of all requests can be upgraded from HTTP to HTTPS. And again, this is where browsers traditionally would connect using HTTP. Only, not even 1/3 of the cases, our HTTPS only mode shows an exception page to the end user, and then again the end user has the ability to either abandon the connection request or connect using the insecure and outdated HTTP protocol. Okay, so now this is great, but now let's look how that looks in the grand scheme of all requests. As you can see here, 92.8% of all top-level requests, or actually of all web page loads, are already HTTPS. Then HTTPS only mode can additionally upgrade 3.5% of all requests from HTTP to HTTPS. And then as you can see here, 3.7% of end users opted into basically allowing HTTP web page loads. So now, how often does an end user experience an exception page? Well, when visiting 1,000 web pages, we can say that the median user experienced 4.3 exception pages. 34% of all users saw no exception pages at all, and 95% of users saw fewer than 50 exception pages. That already shows that HTTPS only mode is practical, and in fact, again, we don't want to eliminate the reachability of HTTP web pages, but we want to flip the model around. And again, it's basically an implementation detail that we show an exception page because we wanted to be very explicit in our implementation of HTTPS only mode. But we obviously, any other implementation could simply implement some kind of automatic fallback to HTTP. Basically, try to connect using HTTPS. If that is not possible, fall back to HTTP. Simply flipping the model around, or the current connection model that we see on the web at the moment. We also upgrade all sub-resources within a web page. And as you can see here, on aggregate, we can upgrade 66.51%. What is interesting here is video and audio. And this is a very small fraction of the overall sub-resources that we see. And again, this is only requests that are HTTP and that we can successfully upgrade to HTTPS. Video and audio are such new content types that they already, mostly what we see, they are already mostly HTTPS. It's worth emphasizing that those requests that we show here, or those sub-resources we show here, are only when they start out HTTP and we can upgrade them successfully to HTTPS or not. Finally, I guess I want to do some advertisement and show you how to enable HTTPS only mode if you want to try it out yourself. In Firefox, go to About Preferences, scroll down to Privacy and Security, and enable HTTPS only mode. In summary, I think what we have seen here in the numbers, and probably most of you already experiencing, HTTPS only mode points the way to a fully secure web. And now is probably a good time for browser vendors to reevaluate their current connection model. Finally, I want to use the time and do a little bit of advertisement for our SURF initiative, which is the second SecEng University Relationship Framework. If you want to work together with Mozilla, with Firefox, and in particular the security engineering team within Firefox, please go to surfmozilla.org. All the information is there and you can simply reach out to us. With that, thank you so much for your interest in HTTPS only mode. And I want to read out one sentence that is very important to me. It's really a privilege to work with people who are passionate about building the web we want, free, independent, and secure. And the fact that all of you are here joining MADWeb is also a signal to me that you are very interested and also want to sit in the same boat for creating that secure web I'm so passionate about. Thank you so much for your interest, and thanks. Take care.